wants to look back up. And thanks, Robert, for posting your link in the chat. So for upcoming sessions, if you do want a chance to practice project delivery, well, I might think about how I want to insert that into these meetups at the end, beginning, however, but just reach out to me if you do want an opportunity to get feedback on practicing that. I'm also building a question bank, so please keep sending me questions that you're coming across each week, and we'll work on them as we go along. At this point, this is our 6th session for the year, which can't believe we've already done 6 of these, but I'm thinking that we'll do 3 more for the rest of the year, and I think the last session will be December 8. I might go to December 15 depending on how people's schedules are, but I kind of just got a feeling people might be winding down from interviews over Christmas, so just to give you a heads up on that. These are the topics that we cover. Essentially, we're looking for jobs including data scientists, data analysts, data engineers, business intelligence and engineers, database consultants, that kind of stuff. So I want to make sure we get a sort of a variety of topics covered for all those sorts of job titles. Today, like I said, we're going to have some presentations, and then we're going to do a SQL question, a coding question based on binary tree and hint recursion, and then a modeling interpretation question as well. So to begin with, I'm going to hand over first to Rule, and I will cut you off after 4 minutes. But apart from that,
sounds good.
You're free. I'll give you a little intro if you like. Rule, can you tell me about something you've been working on recently?
Sure. I'll share my screen. Can you enable sharing? No, host disable participant screen sharing. You have to go to share and hit it.
Should be able to do it.
So yeah. Okay, so a little bit introduction about myself. I'm a graduate student at University of Maryland, Baltimore County, and I'm also working as a research assistant at university, and at the same time I'm pursuing my master's over here. So this work is a part of my research work, and which I will be presenting in one of the meetings called American Geospace Union. So this is the work. So this work is machine learning for emulating physical parameterization for planetary boundary layer height. Let me give you a bit of overview. There is a particle called aerosol. So it can be generated from human activities or natural purpose. Scientists are keen to know about what are the amount of aerosols present in our atmosphere to check about the pollutions going on. So they need this information to take measures regarding the pollution. And one factor is also aerosol helps to determine the height of planetary boundary layer. So what is planetary boundary layer? It is like we know some of the atmospheric layer like troposphere, stratosphere. So beyond that, apart from that, it's the lowest layer of the atmosphere. So with the help of aerosols, we calculate the height of planetary boundary layer. So the current way the NASA is doing is they run a weather research forecasting model, which predicts the height of this layer. But it's a very the computational cost of this process that running that model is very high. The time required to do that is really high. So what we proposed is that we will be using machine learning so that we can predict those layer height with the help of machine learning so that we can reduce the computation cost as well as the time cost. This was the abstract, some of the background work, like we are not the first one who is using to generate the environmental related variables. Some of the MIT's Oxford people have also done it. Mostly method, what approach we followed, as we have said, the NASA model, that is weather research forecasting model. So first we will be taking data from that model. Then we will apply deep learning on that model, and we will try to predict what all data we available. It's a time series data. So with that data, we would predict some further future data as a time series one. So that will be the part of deep learning. And then we would evaluate how our model performed and what were our results. So data set, I said, so predicting the planetary boundary layer height depends on mainly uh, the wind factor and the temperature. These were the factors which is depend on. So we created two data sets. One data set was around 6 days, and the other data set was around a whole year, and little bit more than that. So as you can see then in this visualization, the top two are the wind factors and the bottom left is the planetary boundary layer height, which we are going to predict, and bottom right is the temperature. So these red values are like a bigger height values, and the dark blues are the lower values. What were our results? So we ran two types of model. First was feed-forward neural network, and the other was using the neural architecture search. With feed-forward network, we got some results, but the main approach which we followed was neural architecture search. So how neural architecture search help us is that we just give input data to that algorithm, and it will give us the best architecture that will give best results on that input data. So we implemented it using a library called AutoKeras. So for this data, what we did is the best result which we got were two layer of dense. The activation function was ReLU, optimizer was Adam, and we run it around 100 epochs, and the loss was mean square error. And with the feed forward neural network, what we modeled ourselves with NAS, we did not have to tune our model, but with feed forward network, we tried to tune our model, and there we got three dense layers. We use true dropouts, learning rate was 0.001, SGD optimizers, and RMSE loss. So comparing the results, so first I said that we developed a 6 days of data sets. So clearly you can see the upper one is the 6 day result from feed forward network, and the lower one is the result from the NAS. So as you can see, and the red is our output from the walk model, which was our input data, and the blue one is our predicted. So as you can see, feed forward, it is lacking in some of the ways. It is not able to capture the whole relations of the data, but as you see in the NAS, it's almost capturing each and every point of our model, the WOF input data. We evaluated our model based on RMSE and the R square value, and we got better results of both these values from the neural architecture search rather than in feed forward. And these are the results for the whole year of data. The first one is the feed forward one, and the second one is the NAS model which we worked on.
Awesome.
So again, yeah, again, the NAS model performed really good. So we were able to, and this graph, yeah,
Also,
this graph was,
I'm really sorry to cut you off. I'm going to cut you off.
Okay.
Unfortunately, because that's super interesting. Thank you so much for presenting.
How much time I took?
That was about 5.
Okay.
Bit over. And just to give you, I mean, that's kind of what I was hoping to get out of this experience is feeling what that time feels like. What does 3 minutes feel like? What does 3 minutes feel like? And you got in a lot of information in that. So I guess the question I'd have for you, again, relating back to that interview scenario, what would be your 3 take-home points that you would want an interviewer to, what do you want to convey about this project? What are your sort of either top 2, top 3 dot points that you want to get across?
First one is the application of deep learning for to identify weather-related variables.
Yep.
So first, it's a new approach that we can take some. We can also identify the weather-related variables using deep learning,
Yep.
which is better than the already functioning models,
Yep.
which someone is doing. The second is the neural architecture search. So this algorithm perform really good. So it's a part of auto ML, where we don't have to put much of our head in tuning, but this algorithm provides us a good results for doing this work. So it's a new field. So yeah,
Yep.
for deep learning, it's encouraging new field.
Awesome. I think I definitely heard that conveyed throughout that. I think that's great. Do you want any feedback from people, or was it just a helpful experience just to
No, I want. So yeah, I definitely want some feedbacks that some of I was able to convey what the project is about, even though they don't got the main understanding. Was I able to give the introduction well, giving them whole idea was it, and what all approaches I used, and what was the result? Was I able to do that?
I felt you had a really clear structure. I could definitely follow through you giving the introduction, what your aim was, what your application was, and your results. Does anybody else have any feedback that they want to provide, of especially people who have maybe done interviewing before?
I like that you followed the structure of your presentation. You talk a little bit about the background information, not everybody is aware of, the different layers of the atmosphere, maybe the aerosol, the current methodology and your methodology. I just wish, I don't know, 4 minutes to me is not enough time to do anything. But if you want to do it in 4 minutes, you definitely have to come to your conclusion. And how does your approach compare to the existing approach, and what you learned basically?
Okay.
Yeah, definitely. And exactly right, George. It's definitely not enough to capture the nuances of a project. And I think it's definitely a challenging task, because you want to, how do you capture your key points and show it? Often if we're limited to a 30-minute interview and we've got other questions that they want to ask, I think it's a bit of a dance. But I also think that you'll often have interviews where it is going to be more open discussion to go deeper. So yeah, awesome.
Yeah. Did I give more time to the method one instead of the result one?
I think you could probably summarize your results, and I guess the method is probably the most interesting part that demonstrates your skill a lot.
Okay.
That's my opinion. I don't know if anyone else has different thoughts on that. But
I mean, I think adding a little bit to what George was saying, honestly, I'm not a data scientist, so a lot of this went over my head. But I'm curious, is it well understood why the NAS algorithm in this particular case performs so much better than the fully forward one? I'd be curious about that. Maybe you're going to get to that in your conclusion, but I also wonder if you might want to invert the way you present it so that in a way you get to your conclusion faster. Maybe you start with your conclusion in a way as a summary, very briefly, and then you go back into the kind of, because I would imagine the audience or whoever you're speaking to would have some familiarity with some of these things you're speaking of. So full background and method may not be necessary, but that's just. But I was curious if there is like a clear understanding of why those two approaches yielded such different results.
Okay. Yeah, I got that. Yeah.
Awesome. I do think you spoke really clearly though, Rule. So again, thank you for being brave and presenting and talking about this. And I'll create a channel in the Slack group that a projects channel that if people want to share what they're doing, even just for the interest of the study of the field, please feel free to share the projects that you're doing.
And maybe in the end, if we have questions, can we ask you, Rahul? I mean,
Yeah, sure.
Okay, cool. In the end, thank you.
Thank you, and thanks for being patient with my strict timing. Really appreciate that. Svetlana.
Thank you.
Do you want to share something?
Yes, I didn't prepare any slides, so I just was going to just tell you briefly, as I would in an interview.
Yeah, won't have slides in an interview, so.
Yeah, so lately I've been working with this small startup called Cattle Scan. They have sensors on cows that send information every 15 minutes. And they wanted to analyze information and make some predictions based on this data and some additional data that they had. I got a chance to work on it this summer, and currently still working with them. So the problem is that there is a lot of missing data because, cows don't have very good Wi-Fi for some reason. And that creates big problems for this project. Yeah, because without Wi-Fi, we don't get the signal from the sensors. And also, it was not clear to me at the beginning how to deal with all this sensor data. But in the end, I figured out, so I found ways to extract the necessary data. So we wanted to predict certain events, such as when a cow has a baby calf. I took the data for a few days right before the calving date, and then some data from earlier, and basically trying to predict this binary target, whether the cow would be calving next day or not. And I used feature engineering, tried different ways to construct predictors from this sensor data, and also used grid search CV to find the optimal hyperparameters. And so also I read some research paper that was suggesting some approaches to this. So in the end, I built a pipeline that seems to work more or less well in many cases, but not in all. So now I'm working to improve that pipeline, to consider other problems that we have observed to improve the accuracy of this prediction. But for recently calved cows, mostly we correctly predict when that happens, when we have enough data. Oh, I just checked right now, and again, there is like 85% missing data. Very hard to predict in this condition. Any questions?
So many.
That's awesome. Firstly, thank you for presenting. Secondly, yeah, let's have in our open session at the end, let's open up for questions there, and people can follow up. Really interesting. Thanks, Svetlana. I hope that was helpful for you as well, to practice talking. But I mean, you're already quite experienced with presenting. Awesome. Thanks so much. Oh, awesome. Well, thanks for humoring me on that experiment. That's awesome.
Did you want to ask questions to Svetlana, or should we do that in the end?
I'll make a space at the end.
Feedback.
Oh, sorry, yeah, does anyone have any feedback? Or Svetlana, do you want any feedback on that?
Yes, please.
Does anybody have any specific feedback?
I'll let somebody else ask. I just have a couple of questions, but I'll let somebody else ask.
Again, I think you described methodology quite clearly, and sort of, again, bringing up what the aim, what you were trying to do, and sort of touching on those key points of what you want to convey. You want to convey what you did, why you did it, and what the result was. And I think that was easy to follow along. Yeah, that would be.
Like, I have so many questions too. That's just fascinating. This is coming at the problem space from more of a data engineering perspective, which is my background. But in terms of the inconsistency in the data, I don't know if you had any thoughts on ways that you might be able to mitigate that. It might be more of a systems, IoT solution, but yeah, if I were speaking to you about this as an interviewer, I would be curious to hear what you thought about ways you might be able to improve the consistency in the data that you're collecting from the cows.
Yes, so I looked into possible ways to impute the missing data, and currently, so in order to somewhat mitigate this missing data problem, I'm using aggregation. So I aggregate the data over each 6-hour period and hoping that there would be sufficient data to give me the needed information. And if there is no data at all for 6 hours, then currently I'm just using an average value over the training data for imputation. But I plan to replace it with using average data for a specific cow, because over some previous amount of time, because different cows may have slightly different average temperatures, and so it's more. It should be better. It should work better if I use the average temperature for the same cow.
So I'd be really interested in hearing if there's a way to identify a threshold at which you can come up with accurate imputations. So, if over a 6-hour period you have X% of the data, or there's some spread in the data that is acceptable to come up with an accurate model, that would be really beneficial to like the systems engineers, or maybe even the people engineering the sensors, to be able to come up with ways to meet that SLA, if you want to call it, right?
Yeah, that's a very good question. So the sensor works fine. It sends the signal, but the signal gets lost somewhere if the Wi-Fi is not good, apparently. Or I don't know, maybe some other reasons.
Yeah, I mean, that's a classic challenge with remote devices and sensors. So if I were on that team, I would want to know, like, Svetlana, tell me, like, what is the threshold we need to meet with this sensor and the transmission to make as accurate a prediction as possible, and then we can go back and figure out how to engineer that solution.
Yeah, actually, I think one of my possible projects is to build a model that predicts the confidence in the model, in the prediction that I'm giving. Because currently I'm computing the probability of calving, but actually there is a question of how confident I am that this model works well. And it's not just a linear function of percentage of missing, because it's possible. I also look at the plots of the temperatures, and I see sometimes I can, even with many missing, I can clearly see, yes, it's very likely that this is going to happen tomorrow. And in some cases, I cannot tell. Yeah, it's work in progress. I need to figure out how to quantify what I see to actually measure how good the prediction is. It depends a lot on where exactly those missing are. So sometimes with many missing, I still get very good prediction. Sometimes with few are missing still, I cannot predict reliably.
That makes sense. Yeah, it's interesting.
Thank you.
Thanks, Svetlana. I'm definitely going to create that projects channel so that people can stay up to date with what we're working on. I wish we had more time to spend on it. Yeah, thank you. Michael, you're in your position, given what you just said, does that mean you're a SQL expert?
No.
Is that you being?
I'm okay at SQL.
Our next question is a SQL question, which is why I asked. We do a lot of SQL questions.
That's important. Yeah.
It is. It's almost in every single job description. So something that I have prioritized for these sessions. I guess more for those data engineering positions specifically. So this one, Svetlana brought to me. Thank you, Svetlana. And I thought we would work through together just on I'll put it in the chat, on the interview query page. I know I don't usually do this, but I thought it's just easier if we all have our own editor to try things out. So I'll just post in the chat the link to this question. The hint I'm going to give for this question is that it is a simple query, but the question, it takes a bit of digging in the wording of the question. So we're given just one table, and it represents the search results from search queries on Facebook. So you've got a query column, which is the search term. What did you actually search for? You have a position column that represents each position that the search came in. And then you have a rating column that represents the human rating of the search result from 1 to 5. So 5 being the search result was really relevant, 1 is it wasn't so relevant. So there's two parts to this question. We're essentially going to write two different queries. One, we want to write a query to compute a metric to measure the quality of the search results for the query. And then the second part is we want to be able to compute a metric that measures the precision of that ranking system based on position. So we're given this example here where we have done a search for cat, we've done a search for dog. In this scenario, cat would have a better search result ranking than dog because the position, the first result was the most relevant, the second result was the next relevant, and so on. Whereas dog is sort of mixed up and the relevancy didn't come in order, essentially. So we're trying to write a query, write a query to create a metric that can validate and rank the queries by their search result precision. So I'll give you just a minute just to sort of read that yourself and sort of think about that, and then we'll work on it, work through it together. And try not to peek at the solutions.
Hey, Leona, while I make an account, what is the position referred to? Is that the order in which the queries happened?
It's not the order of the query. This is the order of the result. So if I did a Google search for dog, this was the first thing that came up, then this.
I see.
Yeah.
Gotcha. Thanks.
In this case, Facebook search.
And do we know how many positions we get for results? Do we get just 3 or more?
It doesn't specify. I would assume that it could be endless. So I'd make that assumption that it would keep going. So if you think about searching for something on Facebook, you might get 7 results. So you're going to have 7 positions and so on.
But the ratings are only from 1 to 5.
Yes, exactly. The rating is from 1 to 5. So if you've all had a chance to sort of read through it, let's just start with the first part and then we'll get to the positioning. So write a query to compute a metric to measure the quality of the search results of each query. So I guess thinking through this, can anyone visualize what our output query is going to look like? Like what is one row going to look like?
So probably going to need two columns, one for the query and one for the metric.
Right, so let's sort of pseudocode this out. If we go select, we're going to want the query column. And you said a metric.
Mm-hmm.
We don't have a metric column, so we're probably going to alias something as metric. We'll call it that.
Is it possible to make it larger, please?
Oh, yeah, thanks. How's that?
Yeah, much better, thank you.
Okay. Okay, so yeah, as George said, we're going to have two columns. So if there are two columns, we're grabbing out the query and we're grabbing out a metric. What's a row going to represent in this scenario? Yeah.
Each query gets a row.
Right, right. So in that case, our output query, we determine our rows by how we group by. So in that scenario, we can sort of pseudocode in our group by query.
Mm-hmm.
Some people might do group by one, but you can do group by query. Okay, so we can probably also fill in our from clause. That's a nice giveaway too. We've only got one table, so it's going to be from search results. So is there any more clauses that we would need? Do we need any sorting? Do we need any filtering clauses? Do we need anything else like that to be able to answer this question? Any filtering or sorting or logic?
Yeah, the rank the queries by the search result precision, so I think we need to order by that metric. Maybe descending.
Yeah, if we wanted the results to return with the highest on top, yeah, we could order by that metric that we're going to create. And if we wanted the highest on top, we can do it descending. Apart from that, probably don't need any more logic. All we need to do now is determine what metric to use. And again, we're just doing the simple one first. So we're doing write a query to compute a metric, so we actually get to decide what the metric is, to measure the quality of the search results. So what could be a sort of simple indication of how good, how relevant the results are for each search query?
This looks like a weighted average. We just need to figure out the right formula. So we want to give a higher weight to position 1, and also want to take into account rating.
So
you give lower weight to lower positions, multiply probably by their rating. So if I did this, I probably inverse the position. So 1 over position times rating, that would be a simple metric I would use. Maybe an average of that new calculated field.
So what would be your distinction? Firstly, I 100% agree. And I think that is the solution for part 2, because that's taking into the position. So what is the distinction between question 1 and question 2 here?
Perhaps I'm a little slower, but I might have started with just an average aggregated function of the ratings for a particular query.
Right, because in question 1, it's just asking for a measure of quality. We're not really given much detailed information of how we're measuring quality, other than we know that we have these ratings that give us relevance. And if we're just having 1 row per query, then taking an average of each rating is going to give us a general indication of how relevant the search results are for that query. So as far as part 1 goes, yeah, I would exactly what Robert said, is just taking an average of the rating column, and that could be our metric for part 1. So if we run that, we're going to get an average rating of how relevant each search term was.
It's like a minimum viable product.
We assume that a query is identified by the search term. We're making that assumption here.
We are, yeah. And of course, like most of these questions, there is definitely a contrived nature to it that isn't necessarily the most realistic. One thing, if you have an account with Interview Query, they give you some gotchas or some hints throughout. So one of them was that the problem states to rank the queries by their search result precision, but this doesn't mean to use petition rank rather than to use rating. Actually, sorry, that was the next one. So yeah, this can definitely be a much more complicated problem, diving deeper. But in this scenario, we're more trying to just focus on the practical part of figuring out a metric to develop an easy SQL query. But eventually you would be thinking about, I guess the real world problem would be thinking about click-through rate, or, you know, some sort of metric like that. What, how can we optimize for that kind of thing? So I think as far as getting a simple metric and extracting that with SQL, this is a simple metric to measure quality. And then for part two, we would just implement what George said before. We need it inversely, because we have the situation where 1 represents good and a higher number represents bad or worse. We need to take the inverse of that to weight our ratings column, if that makes sense. So in this scenario, we'd have 1 divided by the position times rating. Is that what you're thinking?
Yeah, but make sure you use parentheses.
Oh, sorry, thank you.
Otherwise, yep, you might be dividing by. There you go, perfect.
All right.
This is a very simple metric. So this one would score the cat better than the dog, but I'm trying to think if there's any combination of numbers that might give you similar results, even though the ratings is not exactly the same. I don't know.
Like if you had like a symmetrical.
Maybe you had a bunch of ones. No, you cannot have a bunch of ones. I don't know.
Yeah, well, I guess that is a point, that position's always going to be sequential.
Yeah, but the rating, can it be all one number? I don't know.
Right, exactly.
It's human evaluated.
It is. But if you think about the 1 situation, you're going to have the average of a third, a half, and sorry, 1, a half, and a third. So I think that's still going to scale.
Yeah, worst case, maybe you just don't do 1 over, you do 1 over position times 10 if you really want to put a huge weight. It depends how discrete or how important is the position to you. I don't know, I'm curious what other people think.
Yeah.
I was thinking you might, I mean, the examples they show here only show, you know, dog has 3 hits and cat has 3 hits, but you search for something that has, you know, many entries, might make sense to only include the top positions in the metric.
Right, so like have a limiting factor.
Right.
Yeah, interesting. How do you have a suggestion of how you might implement that in SQL?
In pandas, yes.
Yeah. SQL is my Achilles heel.
Mine also.
Semicolon limit.
Yes, I agree. I believe there's like you
Is
could
there dot head here.
Yeah. Otherwise, maybe a common table expression like a subquery and just limit.
Yeah. In fact, I believe you could essentially do. I can't remember the exact clause. I think it's like a when or something, where because you're saying you only want the positions. Let's say you only want to take into consideration positions 1 to 5 or something. So you could just say when or where position is equal to or between 1 and 5.
Can you just say where position less than 5?
Yeah, totally. So I guess that's where you'd add in some filtering.
Okay. I guess we're complicated unnecessarily.
Creating our own questions now. Awesome. Well, Svetlana, you brought that question to us. Anything to add or note or?
Oh, that's good. Thank you.
Cool. Thanks again for bringing that, because I think that was, when I came across this one, it seemed complicated at first, but it was a deceptively simple query. So I've just sort of summarized those two solutions there. And then takeaways, I guess this one, just understanding what schemas are representing and what they're telling you, what your columns are, thinking about what some appropriate metrics are, and also simplifying the problem based on a use case. So if you're in an interview scenario and you're given a real world scenario or use case, think about how your metrical solution is relevant to that use case. Cool, all right. Gonna do some Python now. Again, we'll do this one live in LeetCode. Some of you may have done it. I know Svetlana and Robert both do the daily LeetCode challenges. So you might have already done this one. Let me chat this to you, the link. So can I get a sense of, is anyone here familiar with binary trees? Who's already sort of familiar with binary trees, binary search? Yeah, cool. And recursion? Yep, okay, cool. All right, well, in which case we'll hopefully for anyone that this is new for, this is kind of a nice introduction to it. The solution can step through both how we use binary trees and how recursion can be implemented. So here's the question. You're given a binary tree and we're given a range of numbers, low and high. So in this example, low is 7. And we want to sum up all the numbers that are between 7 and 15, or the low number and the high number. Okay, so in this scenario for this tree here, if we're given 7 and 15, then we're going to sum up 7, and then we're going to keep looking at the tree. Is 5? No. 10 is between 7 and 15. 15 is between 7 and 15. So we'll have the output 2. So we just want to sum up all the numbers between a given range. And they've given us another example here. For those who aren't familiar with binary trees, just a quick summary. Binary trees are just that. We have two leaves or 2 nodes per node, and it's essentially got a nested relationship. So we start with 10, and then 5 is less than 10, so we have a left property of 5. 15 is more than 10, so we have a right property of 15. And then the tree continues. Now 5 is the root node. We have a left property of 3, and we have a right property of 7, because 7 is higher, 3 is lower. And then on this side, 15, 18 is greater than 15, so it's the right property. So trees always have a right property and a left property. And in Python, we don't have a built-in data structure. We typically build a class to define a tree node, mostly because it's quite a simple implementation. Doesn't really make sense to have a built-in function. But the class has 3 attributes: the value itself, which is, in this case, the number 10 of this node. And then it has a left property, which again, in this case, this whole tree here is the left property of 10. And we have a right property, which in this case is 15, the subtree from 15. So the solution that we're going to create is going to take an input, which is a tree node, and then a range, the lowest number and the highest number that we want to take the summation from. Any follow-up questions on this question so far? Cool. I'll let you guys who haven't done this question take a couple of minutes to try and answer it on your own. And what I was thinking of doing is physically writing out what our input to this function is going to be, just for anyone who's new to trees. So we're going to create a tree. And the way this class works is we're going to create a tree node object. And again, we have the value, the left property, and the right property. So if we are going to build this tree over here, the value of the root that we're starting with is 10. And then the left property is another tree. So instead of left, we're going to create another tree node and it's going to have a value, a left property, and a right property. In this case, the left property is 5, and then it also has 2 trees left and right of it. So its left property is going to be another tree node. In this case, the value is 3, and its left property is going to be none, and its right property is none because it's just a leaf. And then we would do the same for the right side of 5. So we're going to backtrack to the right. In this case, it's another node. Value is 7, and it doesn't have any left or right properties. So we're going to go none. So we've done the left side of the 10 tree, and now we're going to do the right side of the 10 tree. And again, the right side is another tree object. In this case, the value is 15, and then it has a left and a right property. In this case, 15 doesn't have a left property, so we're going to say none, but it does have a right property, and it's another tree node. In this case, the value is 18, and then it doesn't have any further branches from there. So just to be explicit. So this is the...
Would another question be to construct this from a list? Because your input on the left looks like it's a list.
Yeah, so it is actually a tree node. So it's actually one of these tree node classes. The way they've written it here is a list. So I think it's a little bit deceiving, but when you create this function, it's actually one of these tree node objects.
Got it.
So if you were to manually input it in, it would look like this, but this is essentially the simplified version of. So in this case, you've got the root, left, right, and then you've got the left, right of the left.
Not only that, but if its input is a list, you don't even need binary search tree.
But the input isn't a list. So the input is going to be a tree node object.
Got it. Okay.
I think this is just how they've written it for the example's sake. Yeah. But secondary problem is, how do you solve it if it's a list? But in that case, you're just going to do iterative indexing.
Yeah, LeetCode has a little visualization thing. So if you want to build your own custom test cases, you can kind of construct a tree using that list-like syntax, and it will show you what the result looks like, which is helpful when I was first trying to figure out how this thing actually represented a tree, even though it looked like a list.
Yeah.
If it was a list, it would be just a simple list comprehension with an if statement, so you're good, but no, it's a tree.
Yeah.
But they also tell you that it's a binary search tree.
Mm-hmm. Exactly. Is that visual you were just talking about, is that within this console?
If you go down the page, I usually get underneath the code, there's like a submit button, or no, it says run code there, console. That's it right there. You can actually input in the console. You can change those inputs and design your own test cases.
There's the tree visualizer. Okay.
And if you...
I guess I'd probably need to write it up.
I think if you click in the console, it will show it to you, no? Maybe you have to... Are you logged in? Yeah.
Yes.
I don't know. I've always... Whenever I've clicked in the... Maybe if you click inside the list and start editing the tree.
Yeah, true.
Yeah, there you go.
Oh.
See the little visual pops up.
Awesome.
Shows you as you're building it.
That's cool. Yeah, okay, right. So it abides by the structure of root left right, and then the left right of that one left right. So it's going to keep nesting out.
And you need nulls wherever you have to skip nodes that would otherwise exist.
Null 20, right.
I'm surprised Python doesn't have a built-in binary tree data structure or library. I'm pretty
Yeah,
sure.
I was talking to Jonathan about that this week, and from what I've heard, the consensus is that because it's such a simple implementation, because it only has 3 properties, doesn't make sense to have a full built-in data structure for it. But a lot of the built-in functions use binary tree search, like under the hood. But I mean, it's.
I don't think that's the reason. I think people used to implement this in C or C++, and then when Python came along, like, okay, it's already developed in another language. Why should I develop it in Python? Maybe it's not a core data structure in Python.
Yeah, for sure. All right, well, do you want to try, anybody want to share a solution? I've got 3 solutions today for this. I've got a recursive one, and then Svetlana has shared her recursive. I've got 2 recursive, one that this one suggests, one that is Svetlana's, and there's also an iterative solution that doesn't use recursion. And again, anyone who's new to recursion is when you define a function that uses the function, so a function within a function. So you call the function that you're defining within the definition, which will become clear soon once we actually do it. But yeah, does anybody want to have a crack at how we might implement this, or do you want to just work through it together?
I don't know if there's another way without recursion. You said you have 3 solutions, right? One is recursion for sure. So without recursion, I'm trying to think.
There is an iterative one.
Just a loop one.
Maybe once we see both, we can jump into the discussion of the pros and cons of each. So maybe let's start with the recursive one first, since that seems to be maybe the most obvious way to do it. So what algorithm would we want to use? We need to traverse this binary tree somehow. So what algorithm we're gonna? I guess the most common that you come across with binary trees is DFS and BFS.
Mm-hmm.
Yeah, you need in order traversal.
Say that again, sorry, Svetlana.
In order traversal.
Yep.
In order means first you visit the left subtree, then the node, then the right subtree.
Yep.
And that will give you the correct order of elements.
Totally. And I believe that that's depth first search, right? Because you're exhausting one and then you're backtracking and exhausting the other side. So that's order. That's order. So what does this function need to take? What are we going to put in there?
Tree node.
Yeah. So we're just going to put a node. We're doing this within this. So we're given our root node, and then we're going to given our range. So then what's the algorithm here that we need to essentially move through? Just in plain English or pseudocode.
Well, I think we need to ask ourselves what this DFS function should be outputting.
Yep.
So if it's going to be recursive, you probably want to output for a given node what the sum of it and all of its descendants are that falls within the range.
Right. So that's going to be our base case, right? So essentially our base case is the summation. We want it to do something with that. So what would be our condition for that? So what's the condition that's going to tell us to add it to our sum?
If node.val is less than low and, sorry, more than low and less than high.
Cool. So in this case, if it is in the range, then we'll have some sort of like answer value. And we're just going to add the value to our answer. So that's essentially going to be our check. What's the next thing that we need to check? If we've got our node, what are the other scenarios that we need to check out?
Don't you need to check first that the root is not none?
Mm-hmm. I actually think, what happens in Python if always like to.
So node.val.
If the root is none, you're gonna throw an error if you try to access its properties, like val left or right.
To check
Yeah,
it.
okay, cool. All right. So then let's go if
node.
node.
Just that.
What's our return if it's our sum is equal to 0? So self.answer is going to be equal to 0.
If not,
null. If it's null.
Oh, sorry.
Yeah. If not, no.
No, there's none, then you just return right away.
If not, no, did you say?
Yeah.
If it's, but if it's not null, then we would continue. So aren't we checking that if it is?
No, if not
Oh,
null,
sorry. Yeah. Sorry. Yeah. I'm with you. Okay, I'm on board.
no, if not null, then you return.
Yes. And we're going to return.
Return 0 or I don't know. I return anything.
Yeah.
Okay. So then
Yeah,
the next check would be, so if we're going through, we're checking is, okay, so let's go from here. So 10, is 10 between 7 and 15? Yes, it is. So we're going to add it. And then the next thing we need to do as part of this algorithm is we need to traverse left or right. So then we're going to check if this number is greater than the left side. So we could go if the lower number is less than node.val, if it, just by the nature of binary trees. So if 10 is greater than our lower value, that means we're allowed to go left. So then this is the recursion part, right? If we're allowed to go left, then we essentially want to go through and do the same check on the left node. So that's the recursion part comes in here, oops, where we can then call this function on the left tree.
So I didn't understand why you're checking the value of the current node if it's more than low. I mean, you don't, doesn't matter if it's more or less, right? Does it?
So we want to know if we're going to traverse left or right. So if 10 is not greater than the lowest thing, then that means that we don't even need to check the left side of the tree in this scenario.
Oh, got it. Sorry. Oh, this is already a binary search tree. Got it. I was ignoring that fact.
Yes. Sorry, that probably should be more clear. So we want to check the direction, because if it is, then we're not going to bother. We'd go to right. So at that point, now we have access to this tree down here, and then we can call this same algorithm on this tree. And we're going to go to the top. Is it null? No, and we can keep continuing. So then, what would the final check be in this scenario? Because from this point here,
we have to check if we hit a leaf in the end.
What's that? Sorry.
We have to check if we hit a leaf in the end, meaning we don't have any left or right.
Yeah, so what happens when we hit the leaf? So when we hit the leaf, if we get down to 7, we're going to come to the top. Is the node value in between? Is 7 in between? Yes, it is. So it'll add 7. Then it'll check, is the left node is essentially is 7 less than 7. No, it's not. So it'll exit out, and then it'll actually won't even get to this point. And then your final check, you want to check the right side as well, or the higher value. So we would check if it's, if in this case 7 is less than 15. Yes, it is. So then we want to run the DFS on the node on the right side. So from this point, we're now accessing the right node of this. So then we would run this function again. Is the node null? Yes, it is. So actually, sorry, this doesn't work in this particular function. So I actually am going to get rid of that, which will be obvious. So once we get to this point, 7, we're now accessing the right node, and we're now going to call DFS on 7, on 7's right node, which is nothing. So then we get to this point, is nothing in between? No, so it's just going to cancel out.
I'm confused why that first if statement was removed.
Because
You're gonna get an error right now. It's not. You're gonna get an exception.
I don't. Let me run through it again. So we're checking if right is. Then we'll run this on 7. When we get to, actually, do we even get to 7? Let me check. Let's go from 5. 5 is not between, so we're not going to add it. Is 5 less than 7? Yes. Okay.
No, is 7 less than 5?
7 less than 5. Sorry.
So that one's going to be ignored as well.
This was my solution. This is what happens with recursion. You start to get all in your head. So now we're asking, if we're on the 7th node, is 7 less than 15? Yes, it is. So now we're going to explore this right node of this right node. Yeah, you don't get an exception. I wasn't getting an exception on this one.
Well, node.right is null for 7.
Yeah. No, I know. I 100% see what you're saying. I'm very, very, very confused. This was
You really need to check for none before you do anything else.
okay. All right. Well, we'll go if not, but we don't want to return because that'll exit out of the function. So we don't want to return 0. Don't we just want to add?
Yes, you do
No,
have
you
to
do.
return. You
You
don't
do want to
wait.
return 0 because you're calling that just on a null node.
Oh, right. So it's just going to exit. Yeah. Sorry.
Yeah.
Gotcha. So yeah. Right. So we're going to return 0. Okay. Very confused. Anyway. Okay. So that's the end of that cycle, right? And then that'll traverse back because you'll just start popping out of the previous and come back in, and that'll come to the right. So then what do we need to finish off the exterior function out here?
I have one question. Like, if one node is null, then we might need to check its branches as well, because we wanna. What if a node is null, but it has some values in the branches?
When we say a branch is
Like
null,
5, let's say 5 is null.
so so this isn't a null branch. This is still a tree. This is still it's a leaf, so it's a tree with no branches. So
Okay.
we're referring to the null branches as in this non-existent one, as in 7 doesn't have a node on the right or the left.
I thought we are dealing with the missing values. What if we have no values in the node?
Right,
Oh.
gotcha.
Okay.
No,
Sorry.
no, that you should have valid entries there. Okay. So to finish off this outside function, what are the 2 lines that we need for here?
return answer, right? Some at the end of the day.
Yep, exactly. So first we need to define what self answer is. So it's going to start off at 0, and then we need to actually call our DFS function on the root, and then we'll return self.answer.
Is this a pseudocode or is this code? I'm curious.
This is real code. I'm gonna.
What is, okay, I was about to say, what is L and what is R? You
Oh.
never defined them.
That's why I didn't have the check, because I had an if statement on the outside. That's what I was missing. That's what was driving me nuts.
You can do that too.
I was gonna say I didn't have a return, so I was gonna check that. So oops.
We did a double negation there.
Yes, exactly. Right. Okay. So I did if node, and that takes care of the null case, and then you don't need to return anything out. Okay.
What is L and what is R?
What's that? Sorry.
What is L and what is R?
Oh, L and R are these here, which I think when I first wrote it, I defined it as L and R. So thank you. Oh, it's high.
Or just change the low and high to L and R.
But George, that would be the smart thing to do.
The edit distance would be smaller.
I am, yes, a big victim of that all the time.
Last question, the signature of your function, I don't really use it. Is that heavily used in Python? The
Yeah.
semicolon and the return int?
Oh, this was predefined by LeetCode. I typically, I didn't use that either. That was already written in, that's how LeetCode presents it.
I know, but have you come across other, I'm curious if people use this because this looks more like another type of language, not Python.
Yeah, I agree. Every time I do one of these questions, I have to check up here that I'm in the right language.
It didn't look Python to me at the beginning, that's why I had to ask.
Yeah, agreed. I personally do not.
It seems to me that I once copied one of these into something else and it threw an error in Python,
True.
like that syntax. So I'm not sure if that's even.
Is it a valid Python or is it a version of Python, Robert? Do you know? There's
I don't know.
like a PEP 8 or what is this? I don't know.
This one says it's Python 3, if that's.
But I'm talking specifically about that, dash, the
Oh.
arrow pointing to the int. I don't know if that's, is that real Python there?
Yeah, I'm not sure. Maybe we need a, maybe I'll try and.
Or if you had to return a list or something else.
Yeah.
It is helpful for problem specification to see that.
Yeah, it is to get the output. I wanted to, Svetlana had another recursive one, which is very similar, but slightly different. So I was wondering if you could talk us through that solution, Svetlana, as well. I've sort of written out your solution here, so you can talk through it.
Did the previous one work?
It did, yeah.
Okay, cool.
Yeah, sorry, I just ran it then. It was accepted. Yes, so very similar. This was Svetlana's. In fact, I might just copy this into the editor.
I did this exercise a couple of weeks ago, and I see that I did it with stacks, not using explicit recursion at all.
Yeah, so did you do the iterative way?
Yeah, with the stacks.
That was going to be an
So I can show that if you like.
Yeah, that would be awesome. Yeah.
But we can go through this one first too.
Yeah, Svetlana, do you want to sort of just point out the main difference with this one? With this logic?
I don't think there is much difference. It's just I wrote out those different cases. If the value in the root is below low, equal, between, equal to high, or yeah, I think that's all. And the corresponding, what do we return here? And of course, this is recursive.
Yeah, and I think I guess what I noticed as different was that here I'm defining a function within this outside function, whereas you're actually just calling that same you're doing the single and adding it as you go and return statements. So the logic is exactly the same, but yeah, just a different way to access the function that you're trying to get.
Question is, how do we evaluate them, right? I mean, I guess they return the same answer, but I guess maybe we'll look at execution time or something. Like, how do we know which one is?
Let's see, this one was 40 runtime. Let's see if just runtime being our metric.
This is a small list.
4 by 4.
I think as long as you're not actually, as long as you're taking advantage of the binary aspects of the search tree,
It's gonna be very much the same.
close.
100%. Robert, do you want to share screen yours?
Sure.
Stop.
This one, I think. Can you all see this one?
Yes.
Mm-hmm.
Yeah, so let's see, what did I do? I just created a stack right here, throwing the root on the stack. And then while there's anything on the stack, looking at the node and deciding whether or not to proceed down each child based on whether there could be something in there.
Mm-hmm.
So at first, we're just looking at the value up top, add it if it's inside the range. Look left, but only append it to the tree, like only go down into that next node if its value is greater than your low.
Right, and so is that to cut out the wasted going to the tree, going to that node and then realizing, so you're cutting down on that time?
Yeah.
Rather than, so, because if it is lower or within that range.
Yeah, so if the value, so if you think about what happens at the root, like we had 10 at the top.
Mm-hmm.
So if 10 both has a left node and 10 is higher than the lowest thing you could be looking for, then there might be something lower than 10 in that subtree to the left.
Yeah.
Likewise, if it has a right child and 10 and the high was somewhat greater than 10, then there could be something in its right subtree that's still within the range. So here you're only going to append something that could have a solution.
Right. So do you need the and? Like, can you just check the inequality?
If you don't, then it'll throw an error because if node.left doesn't exist. Like, I mean, I could just check the inequality and then check if node.left exists down here, or maybe I could have something that rejects nulls later.
Mm-hmm.
But somewhere you need to
Right.
stop trying to access properties if the node is null.
Yep. I did this exact thing, but I did the same as my recursive definition where I did the if node again at the start.
So it looks like when I jump back to the problem there, it didn't copy the,
Oh.
but we can. So yeah.
Nice. Which
So the reason that I often go to this as a default because sometimes, I don't know if they specify it in this problem, but I've noticed that LeetCode doesn't always tell you how big the data set is going to be.
yeah.
Which seems like kind of a serious omission, right? It's always nice to have bounds on your problem sizes.
Yeah.
But here Python has a system recursion limit of 1,000, and sometimes if you rely on explicit recursion, it'll hit that, and you'll have to go back and adjust it.
That's a good point. The constraints for this one were all nodes are unique. The number of nodes in the tree will range from 1 to 2 times 10 to the 4, and then the max node value is 10 to the 5.
Right. So if there's 2 times 10 to the 4, that's 20,000 nodes. That
Yeah.
could exceed your limit.
Yeah. Yeah.
The test cases don't always probe that though.
Yep. Yep.
Keeping in mind that when you call recursion, you are using resources in Python, right? So maybe it'd be better to check if your left and right nodes exist before you do recursion. Maybe that's why it's a little bit faster.
Right. Well, I think it's also it's not doing the recursion, so it's not creating this function call stack.
Exactly.
Like the actual stack, instead of relying on Python's function call stack, it's just, I just created the stack myself.
No, you don't need the stack. I'm saying Ileana's solution. Just don't call left on right. Just check before you do that if the left and right exist.
Right.
Oh, right. Yeah.
Which and are you talking in this recursive one, or?
Yes.
Yeah.
So before you do that,
essentially that check happens here.
Yeah, but you call the function first,
Right.
Then you allocate resources, and then you come out of it.
Right. Right. Yep.
Instead, you can cut it off by doing an and here.
Yeah.
To the if statements.
Yep.
I mean, the answer is the same. It's just I'm curious. I think it might be
yeah. It
might be a hair faster.
My where are we? Oh yeah, my iterative solution was exactly the same as Robert's. I just had this if node instead of the and. So
I'll be honest, I'm a little bit skeptical with while. just make sure that you can come out of them. So.
Well, the nice thing about a code like this is you can see that every single node gets appended no more than once and will eventually pop.
Yeah, you're always popping at the start. Cool. All right, well, that was 3 solutions. Feel free to share if you have any others. Actually, technically 4.
I guess I can, I don't know if you want me to actually share the code that I had, but you have basically the same thing.
Yeah, as always, sharing the Slack.
I can share the Slack, yeah.
Down to model interpretation stuff. This one I thought could be just, I knew we were going to go over time a bit today because we were doing the chats, and we are at 4, so we're down to sort of the OG group, mostly the DLA group here. So up to you. I don't know if you guys want to call it, we can. This is a logistic regression, which I think everyone here is kind of familiar with these kinds of topics. So I don't know, what do you want to do? Do you want to chat about this, or do you want to call it?
Let's keep going, I'd say.
Okay, happy to keep going. I put this one in as just an easy one at the end, since we had sort of slightly more challenging ones earlier. This was another interview query one. Yeah, so thoughts on this one? Specifically, this one's asking for categorical and Boolean. How are we treating them different, which ends up being the same problem anyway, I suppose. But I guess I would open this to a discussion of interpreting discrete coefficients in linear regression, or coefficients of discrete. categorical Boolean variables and logistic regression. You look tired, George.
I'm trying to understand this. What does it mean and how to interpret it?
Oh, I'm sorry. Okay. So thanks.
Basic question.
Thank you. Yeah. So how would you interpret coefficients of logistic regression for categorical Boolean variables? So actually, I might even just click through slides and we can sort of just maybe chat about it. I found some examples. Again, I'm stealing people's photos. This is Tim Bock's photo. This is for a logistic regression model fitted to a churn data set. So they've got a bunch of variables here, and these are our coefficients here. I think he did this in R. So what meaning can we extrapolate? So we'll ignore the intercept one. Senior citizen is a Boolean. Are they a senior citizen? Are they not? Tenure is how long they've been with the company. And I believe it's discrete. I believe it's 1 year, 2 year, 3 years. The internet service, there is 3. There's no internet service, DSL and fiber optic. And then there's contract terms of 1 year, contract of 2 years. And then there's a monthly charge, which I believe is continuous. And so I thought this would be a good example to sort of talk through in the Boolean variable scenario and the categorical scenario. What are our interpretations? How do we interpret these coefficients in this model?
So as a first question, just trying to interpret the outcome variable here.
Mm-hmm.
Is positive an example of customer churning and negative is they stayed?
Yeah, good point. So yes, our output is churn or not churn, and we are, yes, positively is indicating churn. Exactly, which has kind of just answered point 1, the sign. The sign is indicating. So obviously they have one hot encoded our categoricals here, so that's why we don't see the non-internet. But we do have the Boolean variables are flipped 2 sides of the same coin, like you said. So yes or no. So when we're saying that senior citizens do influence churn positively, the opposite is true, that younger people churn less. So it's that inverse on the Boolean. So I guess there's kind of maybe 2 main things we can talk about. There's the magnitude and the sign. So what would it mean in the categorical sense when we've got two positive coefficients, but they have different magnitudes? How would you sort of speak to that interpretation in the categorical realm?
So one question I would ask is, have the categories been standardized?
Yes. So
we're looking at like 0, 1?
When you say standardized, do you mean like encoded standardized? That they have been encoded out in the model?
Right, meaning that they're categorical, so presumably they're numerical, but the values, are they on the same scale for all the categoricals? Yeah.
So for this particular output, we've assumed that they've done all the heavy lifting in the model input to standardize and encode. Dummy out.
What model produced this? Is it like a tree-based model?
This is a logistic regression.
I guess I don't use logistic regression every day, but okay.
So for example, on the tenure front, when we are interpreting tenure, which is it's moving up year by year, but it is still discrete, it's having a negative effect in that the longer the tenure, if someone's been with the company 10 years, they're less likely to churn. So we've got negative because they're not going to churn. And as that value increases, it's less likely that they're going to churn. So in this scenario, that's, actually, I wonder if they're using this as if it is continuous. I'll have to check if it was continuous or if it was a discrete increment variable. But the interpretation here, as far as the interpretation, is that it's inversely affected on churn, which is a good thing for the company. And it also has a small effect. So not as much as what having fiber optic internet connection has a really high effect on positively on churn. And on top of that, fiber optic we can interpret the magnitude in that it is almost double the churn rate as DSL.
So the tenure has a very small churn, but a very significant one.
Right, exactly. So
Why do you say significant? I mean, it's almost close to zero.
The Z value is as far from zero, is the farthest from zero of all the features being considered.
I guess I need to learn more about logistic regression. This is not a model that I use.
The same is true on that note. If you're going to look at Z values, which is a good point, with the monthly charge, you've got 0, but we have a positive Z value here, and you can't, like, these should be the same. Your Z and your coefficient should have the same sign. So this is assuming that it would be a rounding error. And that makes sense. If you're going to have a really high monthly charge, you're probably going to have more churn on those customers, but it's just probably a very small churn. So it's so small, but you can see that it actually isn't 0. And I have a link to this article if you want to sort of read more in it, but they show more examples where someone has an $8,000 churn, a charge versus a $50 charge, but that it actually has quite a small impact, surprisingly, even though it is a little bit positive towards more churn.
So are you saying here that people who have fiber optic are almost double as likely to churn than people who have DSL?
Well, I personally am not saying it, but
So was there a third category for internet service that isn't shown?
Yes, no internet.
No internet. Okay.
No internet. So
No internet.
So they're the three categories.
Meaning what? Like, is there other service that this provider gives, like phone or?
Well, I'm just assuming that these are the results of one hot encoding a categorical that had 3 variables.
Exactly.
And removing the redundant one.
Exactly, and so that's why senior citizen also had a no column, but was dropped in the encoding, the one hot encoding. Exactly. I'm not sure about contract if there was a no contract one. I'll have to check on that one.
Sorry, when you say dropped, what do you mean?
So when you one hot encode your categorical variables, if you have 5, you drop one of them because you're going to get redundant information. Or even if you think about 2, if senior citizen is yes, I know that senior citizen is no for the corresponding column when you want to hot encode that out. I don't know if I explained that very well.
Sure.
So you're not going to have a yes and a no column because your 1s and 0s in the yes column. If you have a 0, that's going to mean no in the other one. So you're going to have a complete
column that has yes, and if it's not a senior, then it's null, or is it no?
When it's encoded, do you mean?
Yeah.
Yeah, so when you originally one hot encode a binary column, you'll have a yes column and a no column. And because that's for the same variable, you're always going to have 1 0 0 1 0 1 1 0. They're always going to be complement. So you've got redundant information here. If there's a 1 here, you know it's going to be 0 here. If it's 0 here, so you can
drop a yes column.
Yeah.
And it has 1s or 0s.
Exactly.
And more to the point, you have to drop one column for a logistic regression or a linear regression or any model like that. Otherwise you're going to end up with instability in your model results itself. Right. If you have any one feature that can be expressed as a linear combination of other features.
Yeah. totally. I believe in pandas it is drop first equals true.
Is there any code about this in the link that you'll be sharing? I'm curious.
Yeah, I think this one is R, so I don't know if you're familiar with R. I have the result, I have the links here, so I'll share those with you. I was going to talk about log odds as well. So some of the summaries I had sort of for this question with interpreting coefficients was that the sign of the coefficient relates to whether the predictor is positively or inversely affecting the outcome. So in that churn one, senior citizen is a positive coefficient, meaning it does contribute towards churn. If it's negative, it's not contributing towards churn. They didn't churn, so it's that inverse effect. Magnitude of the coefficient gives a sense of the size of the effect of the outcome. And then your categorical variables should be one hot encoded. And then that will be interpreted in the same way that you would interpret a Boolean variable, because you're just going to have a bunch of columns that are now just Boolean values. And again, for that same reason of inheriting rank to one hot encode, and also what we just spoke about. And then the other thing that we can do with the coefficients is discuss log odds, or the odds ratio. So if we think about another example, I have another link here which I'll give to you, which is a logistic regression model that was predicting whether someone had diabetes or not. And so one of the variables was gender, a binary Boolean variable. And so we can represent the log odds of the variable happening when all the other variables are fixed. So to find that, we can, that's what the coefficient is going to represent. So I have a slide on that too. So let's say we have the gender variable coefficient is 0.6. We run our logistic regression model, and then the coefficient attached to the gender variable is 0.6. So essentially what that is telling us, in our logistic regression model, we have our coefficient to each of our variables. In this case, male is 0, female is 1. When we multiply that out, we can understand that the odds of females getting diabetes over the odds of a male getting diabetes is 1.8. So this is the log odd. So when we take the exponent, we get the odds itself. We're essentially cancelling out that log. So then you can make conclusions about the odds of females getting diabetes or males getting diabetes in that way. So I don't know if this question would specifically relating to log odds, but I thought it was an interesting thing that you can also talk about when talking about logistic regression coefficients, to be able to, given that we're in the logistic regression world, you're imposing the logit function essentially on your linear regression model, and we know how to interpret linear regression coefficients. So I thought the log odds was an interesting sort of follow on to that. Yeah, sorry, I feel like I did a lot of talking there.
Well, I'm glad you did.
But
I model that I use, so thanks for doing that.
Yeah, I will share all these resources here. When I share the slides, you can click on these, but this Medium article was interesting for the odds example, the diabetes example. And then this Tim Bock article also talked about, that was the churn data set. So he has further discussion there on that. But I thought they were kind of good examples too, because they had good variables. They had categorical, they also had discrete and Boolean. So it was a really tangible example, I thought, to talk about this. And then there was another Medium article I found that was sort of interesting. Yeah, that's all I have for today. Yeah, so thanks for hanging out with me again.
Our pleasure.